Alright, hello guys. We are going to go through the 2023 paper today. So, again, if you are lost, if you need help to start, this can be a good guide as a start of revision. You can do it together, right? But on top of just going through, or on top of just using this as a guide and then attempting with me, it would be good if you can try again, right? Attempt it yourself. Right, so it's on Google Classroom. The papers, your whole compilation booklet is on Google Classroom. Go and try again without the guide. Right, so one round with me and one round without. And for those who are good, who attempted this yourself, you can use this as a means to identify where your errors are and how you can make your corrections and how we can what are the thought processes so that you can get the right answers in the future. Okay, so we're going to do the 2023 paper. So let's begin. Okay, which statement about a physical quantity is true? Okay, so physical quantities, remember, physical quantity, these are quantities with magnitude and unit. Okay, and there are two types of physical quantities. Okay, physical quantities are things with magnitude and unit, and there are two types of physical quantity. That means they magnitude, right? They have their number, a number, a value to it, plus the unit, because you need to define, or rather, for example, I have two what? I have two hands. I have two what? Two legs. So that legs, hands are my units, right? I have this is maybe 15 what? 15 cm, 10 cm, right? 10 to 15 cm, right? So that is the number, numerical magnitude, plus the unit. So in this case, cm, right? If not, you it is not a physical quantity. You don't know what exactly I'm actually describing. And there are two types of physical quantities. Sorry about that. Two types of physical quantities. We have scalars and vectors. Okay, always remember, whenever they ask you what is a scalar, what is a vector, or tell me what's a scalar, define what's a scalar, define the vector, very important. There are two things. They have magnitude, that means they have the number itself, and for vectors, there's direction, right? So you need to ask some direction. Okay, so vectors, yes. Scalars, no directions. Okay, but whatever it is, they will always have a magnitude, they have the number, and they will have the unit. So the answer is A. Which option is considered scalar quantities? Okay, this is something you have to go and memorize, right? Scalar quantities, sometimes it's better to memorize what is not a scalar quantities, right? So your displacement, velocity, acceleration, these are not scalar quantities. These are vector quantities. Anything that is a force, it is not, any force is not a it's not a scalar. They are vector quantities. Okay, energy is a scalar quantity. Yeah, pressure is a scalar quantity. Okay, so these are example of maybe more common vector quantities that you know. So under force, we have weight, right? We have tension. These are examples of forces, right? So all these will fall under vector quantities. So which one has a vector? Force, immediately no. Force again here, no. Velocity is not, right? Distance, time, energy. So far, this is one with all scalar. Distance, velocity is not. Weight is also a vector quantity. Okay, so the answer is C. Question 3. The diagram shows a digital micrometer screw gauge being used to measure the thickness of a 50-cent coin. Given the actual diameter has a zero error of minus 0.001 mm. Oh dear. Has a zero error of negative 0.001 mm. What is the actual thickness Okay, so always remember actual is equals to measured minus 0. So here, what is the measured here? Right, they give you the measured, which is 2.064, minus the 0, which is negative 0.001. Okay, so it's 2.065. Okay, this is something which you need to memorize, that the actual reading is always measured minus 0, the 0 error. A pendulum bob oscillates between point P and R, right? If the time taken for the pendulum bob to swing to point P to point R is 0.2. Okay, so it goes to here. This whole length is 0.20 seconds. What is the period? So remember, period is when it goes back, it will have to be one whole cycle, one complete oscillation, right? So when it cycles back. So P to R is 1, but then you can still go back to R back to P. Only once it reach back to the original position P again, then it will go back to, then we can say that subsequently this is it repeats itself, right? So this oscillation starts at P, it should end at P at the same also. Okay, so there's P to R is 0.20 seconds, so we know that R to P is also 0.20 seconds, so it's answer is C. Question 5 shows the distance time graph of two cyclists. Okay, remember from our 2024 paper, Ali said that when you have distance, the kinematic graph, immediately write D S A. Okay, D S A. We are looking at distance graph, so if you want speed, we take the gradient. Right, anything to the right is the gradient, to the left is the area. Okay, traveling in the same direction on a straight road. Which statement is correct? Cyclist X is moving at constant speed. This is X. Is it constant? Look at the gradient. No, it's not. It's increasing, right? The gradient you can see is getting steeper and steeper. Gets steeper and steeper. So this is the speed is increasing. This is wrong. At 9:20 seconds, cyclist Y overtakes cyclist X. Is it an overtake? Cyclist Y overtakes? No, it is the other way around, right? Cyclist X is the one that overtakes, right? Here at first is behind, right? Cyclist X is behind and go in front. Cyclist Y already in front, right? Cyclist Y moves at constant acceleration. Oh, let's look. Acceleration is one down further. So how? Let's look at the speed first. Before we go to acceleration, let's look at the speed. What do we get about the speed? We look at the gradient. It is a straight line, so it's a constant gradient, right? So constant speed. So if it's constant speed, is that acceleration? No acceleration, zero acceleration. So it's wrong actually. At time 20 seconds, both cyclists have traveled 100 meters. So let's see, at time 20 seconds, this is 100, X is at 100, Y is also at 100. So the answer is D. Okay. So this habit of DSA is very important. Okay, so understand, I want speed, I look at gradient. So it's very important. The DSA, please don't underestimate how important it is. They give you a speed time graph, you are always reminded, if I want acceleration, I should look at gradient. If they talk about distance, I should look at the area under the graph. Okay, let's move on. Question 6. Car is moving at constant speed. Very important. Constant speed. Constant speed, we can immediately put at A equals to 0 meter per second squared. That means no acceleration. Okay. Why is this important? Because sometimes this question may not be the case, but if suddenly the question may be asking about resultant force, then I know that every time I see constant speed, acceleration equals 0, that means F net is equals to 0. Okay, so but let's continue reading. Of 20 meter per second, constant speed of 20 meters per second along a road. So we know that the speed of the car is 20, or you can put S equals to 20 meter per second. When the brakes are applied, constant deceleration. So now got constant deceleration of 5 meters per second. A is equals to negative 5 meter per second squared for 3 seconds. T equals to 3 seconds. What is the final speed of the car at the end of 3 seconds? So let's see. we have -5. Okay, first and foremost, again, please go and memorize your formulas. It's very, very important. Okay, so go and memorize your formulas. You get A is equals to V minus U over T. Okay, so you need this formula, right? Means -5, right, is equals to V. I don't know what's the V. The V initially is, here we know V is 20 meters per second. And then the final speed, I don't know, divided by time, which is 3 seconds. Right, so -15 equals to 20 minus U. That means I times 3 on both sides. Right, bring up the 3. Okay, and from here, I get U is equals to sorry. The other way around. Sorry, yeah. This is U because this is the initial, right? This is initial. Initial is 20 meters per second, not V. Yeah. Okay, so the initially is 20 meters per second, then it decelerates. Sorry. So we are looking for V. So V minus U over T, this is correct. So it is actually V minus 20, the initial. Sorry about that. V minus 20. We are looking for V. So we know that V is actually with -15 plus 20, which is 5.0 meter per second. Okay. Sorry about that. Okay, now. So that's question 6. Question 7. Mass has a gravitational field strength. Mars have a gravitational field strength of 3.70. Have the habit. Immediately write this information. 3.0 Newton per kg. Which option shows the possible mass and weight of an object in Mars? So we have to use what formula here? W is equals to mg. Okay, so this formula, another one important formula you need to go and memorize. W is equals to mg. So we have G, which we know. So maybe we need to use G equals to W over M. So make sure that your W and M, the weight divided by mass, will give you 3.7. This is something which you can do. Question 8. Which statements about friction are true? Okay, there is no friction in liquid and gas. No, we have air resistance, right? So this is not true. One is out. Effects of friction can be both positive and negative, yes. Right? Positive effects of friction. Think about it. We have slow something down, slowing an object, right? Oh, we also have generating heat, right? So a lot of positive effects of friction. Negative effects also a lot, wear and tear, and so on and so forth. Right? We have wear and tear, like your shoes, right? After a while, you need to change your shoes. Friction is, so this is 2 is correct. Oh, and friction is a resistive force because it acts in the opposite direction to motion. This is true. So it's C. Question 9. Two forces acting in the diagram, resultant force. Always remember result. Okay, what is the resultant force? F net. Of course, we have the formula F net is equals to MA, right? But we are just looking for the resultant force. They give us two forces here. One is to the right, one is to the left. So we take 40 minus 32. And you get 8. And then you need to tell and say, is it more to the right or more to the left? Okay, it's more to the right. What happens when forces acting on an object are balanced? Remember, whenever it's balanced, right, we have balance and unbalanced. So if you all remember when I went through with you all the big idea on forces, we have two types. We have either it is balanced, if they are balanced, it can be two things. That means, okay, number one, F net is equal to 0. So what does F net is equal? if net is equals to 0 means all the forces, they cancel each other out. So upward forces equals to downward forces, rightward forces equals to leftward forces. So F net is equals to 0, number one. Number two, but the result of that is if they are stationary, they will remain at rest. And if they are already traveling, they will be traveling at constant speed. But if they are unbalanced, that means there is a F net. F net is not equals to 0. F net is like the one on top, right? 8 newtons to the right. There is an F net. We will use the formula F net is equals to ma because they are accelerating. And in which direction? In the direction of the resultant force. Okay. So in this case, it cannot be accelerates. It cannot decelerate. It doesn't change its direction, but rather it moves with constant velocity. Okay. Which statement about action reaction forces is correct? Right? Action reaction forces. Okay. Remember, action reaction forces, four things, four principles. Right? Action reaction pair. There are four things we need to know. Number one, that they must be the same size, same type of force. If it's friction, then it also be friction, right? If it's weight, then it's also maybe gravitational force. If it is if it is normal force, then it's also normal force. They must be the same type of force. Number two, they must be the same size, same magnitude. Okay, when size mean magnitude lah, right? So if let's say I push the wall 5 newtons, the wall is pushing me also 5 newtons. So must be same size, same magnitude. The next one is they act in opposite direction. And last one, number 4 is they act on different bodies. Okay, so which one? Equal forces, all of them says that they're equal. And then they says opposite forces, yes. So this cannot be in the same direction, right? They're opposite, right? Think about it. I push, if I'm pushing my right hand, my left hand is also pushing me. My right hand is pushing my left hand to the left. My left hand is pushing my right hand to the right. Okay, so they act on, they're opposite in direction, and they are acting on different bodies. Okay, done. Question 12. A man pushes a 10 kg box along a frictionless surface. Box gain 125 joules in the kinetic energy after the push. What is the speed of the box? What is the speed of the box? We have some energy here in the kinetic store. So we need to go and memorize our formula EK. This is M equals to 10. Right, we must memorize our formula EK equals to half mv squared. Okay, so 125 equals to half times 10. And then after that, you manipulate the algebra. Question 13. An object of mass 1 kg is dropped from a height of 1 meter, and the energy in its kinetic store and gravitational store vary at different heights. Some heights and energy is shown on the table, in the table. Okay. Which option shows the, okay, let's look at KE. KE, we see that the KE is increasing as it goes down. Makes sense, right? EK increases as it goes down. GPE decreases as it goes down. So which option shows the correct amount of energy in its kinetic store and gravitational potential store when the height is 0.4 above ground? So we know that it has to exist between 4 and 8. All these options exist between 4 and 8. GPE, it must exist between 6 and 2, and all the options exist between 6 and 2. What else can we do? What else can we do now? What we can do is to make sure that the total energy is also the same. So we must know that this one is always equals to 10 joules. The sum of this is 10 joules. Sum of this is 10 joules. Sum of this is also 10 joules. So energy is always conserved. Okay, so which one give me a sum of 10 joules? This one give me a sum of 10 joules. This one give me 10. This one give me 10. This one give me 12. This is out. right? This is out. Okay, and the next one that you can see is also, right, next one, another thing that we can know is there are two ways. Either you see that this one decrease by for every, this is for every 0.2 meters, it decreases by 0.2, the mgh, right? So it decreases by 0 joules, 2 joules, so this should be 4.0 joules, and then 6, and then if you had a 0.8 here, right, it will decrease by 0, this will be 8 joules, right? So this is another way we can do it. Okay, the another more tedious way is actually we do mgh. You know EP equals to mgh, so at the start we can already find the mass first, right? We know that 10 joules is equals to m. I don't know the m. They never give me the mass of the box, right? Oh, they did. Oh dear. Sorry. See, this the why you need to go and read all the information first. So m is equals to 1.0 kg, drop from a height of 1.0 meters. See what happens when you don't read the question, right? So it gives you already actually. So actually from here already, I can don't waste too much time. I can actually immediately go and calculate, right? So EP is equals to mgh. We know it's 1. G is always 10. And height is 0.4. So you get 4.0 joules. Okay. So it must be C. Okay. This one. A box of mass 2 kg is being pushed. Okay. So if I don't want to repeat the same mistake, I better write down M equals to 2 kg. Push horizontally on a smooth surface by 10 Newton force for 6 meters. F equals to 10 Newtons for 6 meters. So distance equals to 6 meters. As shown in the diagram, what is the work done by the 10 Newton force? So I know work done equals to force times distance. So I go and substitute from my values. Right, these are my values that I have. So I'm going to use my 10 and my 6. Question 15. Machine lifts 2000 newtons of brake. So F is equals to 2000 to a height of 30 meters. H is equal to 30. Above the ground in 50 seconds. T equals to 50 seconds. What is the power of the machine? So we know the power is work done divided by time, which maybe we know force times distance divided by time. Okay, so force we have, distance will be the 30 meters, it goes up, and then the time is 50. Question 16. Attractive force, average attractive force and average distance between particles in solids and liquids are different. Yes, so you must be familiar with your FAM. Okay, so we know that for solids, they have strong attractive forces, they are very close together, right? The average distance is, so has to be C or D. And we know that the distance, solids are more closely packed, right? So it's also average distance is smaller in solids, larger in liquids. Substance is cool down. Again, remember, cool down, I'm going to talk about, maybe I need to talk about internal energy, right? So I know that internal store, energy in internal store is going down, right? Then you can just scribble here, internal store. I have EK of particles and EP of particles. Okay. EK is always related to temperature. EP is always related to state. But at what state? Okay, so which parts of the graph shows a decrease in average kinetic energy? Okay, so we know that when there is a decrease in temperature, there will be a decrease in kinetic energy. So K and M, no change in temperature. So this one, the decrease is in the potential store instead. M decrease is in the potential store instead. So the one that as I change in temperature is J and L. Which 18, which best conductor of thermal energy? Remember, thermal conductors, best is all these metals because of the electrons. Then after that, we have solids. And then the worst is gas because they are very far apart, right? They are arranged very far apart. They collide less likely. So the answer, the best one has to be a metal, is C. Which row correctly describe conduction and convection of heat? Conduction can happen in solids. Yes, it can happen in solids. When it happens in fluids, no, that's not true. Right? Convection, for convection, right? We know that this cannot happen in solids. Why? If they ask you why, because solids they are vibrating at its fixed position. It does not move. Particles are unable to move. Right? So it has to be B. Only in fluids. A double glazed window has a layer of air between two panes of glass. So again, if I see double glazed windows, air, I know immediately I want to write poor thermal conductor. Okay, which best describe how the window helps to keep the house cool during hot weather, right? So which one is the poor conductor? All air is the poor conductors. Glass is not really a poor conductor because glass is a solid. So air is a poor conductor. And then keep the house cool. So we don't want the reduce of the rate of heat transfer into the house. We don't want heat to be coming into the house, right? But we want heat to go out the house. Okay. Section B. Complete the table. Remember, the girl made kids, delicious cookies, making me naughty. Means your 10, 12, 10, 9, 10, 6, 10, 3. 12, 9, 6, 3. Then -1, -2, -3. Sorry about that. Something's wrong with the title sometimes. -3, 6, 9. Okay. So nano is times 10 power -9. Kilo times 10, 3. And giga is capital G. Remember, MGK, TMG is, TGM is all capitals. MGT is all capitals. The rest are all small letters. And one U here. Yeah. Figure 2.1 shows a speed time graph. Immediately, I go and write DSA. Speed time graph. I'm going to look at gradient here to get the acceleration. And distances here to get area. Describe the motion. Every time they talk about motion, there are two things that you want to do. You want to actually describe the gradient. How is the gradient like? What is the gradient like? Okay, so from 0 to 5 seconds, you know that there is a constant gradient. It means it's traveling with constant acceleration. What's the gradient means acceleration, right? Our DSA, gradient means acceleration, right? So when you look at 0 to 5, that is traveling in constant acceleration. 10 to 17, it's also traveling with constant, but the gradient is going down, so it is constant deceleration. Okay? Now, calculate the total distance traveled by the car. Now we know that I want distance, so I just take the area. So can you see how beneficial it is to have actually to know this DSA? Immediately I know total distance. I'm going to look at the area now, right? So I go and calculate the area, go and find what's the area under the graph. Hence, calculate the average speed. Always remember, when you see average speed, first thing you do is to write total distance divided by total time. Total distance, what you found just now, total time is 17 seconds. Figure 3.1 shows a motorcyclist riding a motorbike. Total mass of the motorcyclist and his bike is 220 kg. So I must go and write M equals to 220 kg. Engine provides a driving force of 400 newtons. So F is equals to 400 newtons. Sorry about that. Huh? And the bike accelerated from rest to 25 meters per second in 20 seconds. So from rest, so just now, let's not make the same mistake. Huh? U is 0. 25 V is 25 meter per second. T is equals to 20 seconds. Calculate the acceleration of the bike. Okay, so what's the acceleration formula? A equals to V minus U over T. 25 minus 0 divided by the time, which is 20 seconds. Okay? Can? Okay. So your answer should be 1.25. Huh? Go and check. Okay, and show that the resultant force of the bike is 275 newtons. So what's the formula for resultant force? Resultant force formula is F net is equals to MA. Right? You all remember as F net equals to 1 G, right? MA. So we have 220 times 1.25. And you will get 275. Okay? So you have shown already. Okay? Now, when the resultant force of the bike is 275 newtons, calculate the air resistance against a motorcyclist and his bike. So it's important we write F net is equals to MA. Usually we write F net equals to MA, but now it doesn't make sense to write F net equals to MA. So what else can we use? We can use that they are asking for air resistance. So air resistance friction usually we represent by small f. Right? So usually we can write down as F net equals to F minus F. Means F, big F, the forward force minus the friction or the air resistance in this case. So we know that forward force is 400. So 275 is equals to 400 minus the small f. So what is this small f? Small f is 400 minus 275, which is equals to 125 newtons. Okay, next question. Alan is a mountain climber. His mass is 60 kg. M is 60 kg. Taking G equals to 10 newtons per kg, calculate the energy increase in his gravitational potential store when he climbs a mountain which has a vertical height of 780 meters. Okay. So EP equals to mgh first. Vertical height, h equals to 780, right? Meters. So his M 60, G is always 10, H is 780. Or G is 10 in this case, and 10 if they don't define you what. If they never tell you what G is, you always take G as 10. Okay? So you will get your answer. Whatever answer that you find here. They state useful energy stored in Alan's muscles before he climbed. So what is the store stored in the muscles? Right? So the store stored in the energy stored, which stored is in the muscles. Right? Think about it. This is always your chemical potential store. So you have all the okay. Whenever you think about batteries, whenever you think about food, muscles, oil, energy, stored energy, usually before we do something, that is chemical potential store. Okay, which store, when he returns to the starting point at the bottom of his body temperature is higher than before. So he's returning to the bottom of the mountain, so we know that EP is going down. His body temperature is higher than before. Oh no, so that means his internal store is increasing. Take one box. Which energy increase energy? Or definitely his internal store. James has been asked to find the density of two substances. Okay. James has been asked to identify the density of two substances, steel and water. Right, length and breadth of height of steel are measured. So we have the length, breadth, and height. State the instrument used to measure this length. Okay, Now, very important. It is whenever we ask for instruments, usually the best instrument we use, right, is we use a digital micrometer screw gauge. If not, we will use a digital caliper. If not, it's the meter ruler or the measuring tape. And every measuring instrument has two things. It has its range and it has its precision. Means what is the smallest division that it can measure. So the range, the litmus test for digital micrometer screw gauge, as much as you want to try to use the digital micrometer screw gauge, but there is a value whereby after this value, we cannot use digital micrometer screw gauge because it's simply too big. So what is this? This value is 2.5 cm. You see 2.5 cm only, more than 2.5, I cannot use my digital micrometer screw gauge. This is quite important. This you have to go and memorize. But it's a very simple value, 2.5 cm. Okay, circuit 3. 2.5 cm. Okay. What about digital calipers? As for digital calipers, the maximum is 15 cm. Whereas meter rule is 100 cm, and measuring tape is several centimeters. As for the precision, it is easier to memorize from a digital caliper, 0.01 mm. Okay, it measures 0.01 mm, right? And digital micrometer screw gauge here is 0.001 mm. Just one more, so it's even more precise. Okay, so it's actually, if you convert to cm, it's 0.001 cm. Okay, but in this case, they put into 2 dp. Okay, it's fine. So this is the old vernier calipers, usually is the one that is 0.01 cm. Meter rule is 0.1 cm and measuring tape is 0.1 cm. So the most appropriate is digital calipers. Actually, here is vernier calipers lah. That's fine. Digital calipers. Calculate the volume of the steel block. Please, you need to work with your math teachers, right? Your volume of your steel block is your length times breadth times height. Go and find. The mass of the steel block is 6.62.4, so M equals to 62.4 grams. Calculate the density of steel. Density, we just write the formula first, equals to M over V. Rho is equals to M over V. M, you know, 62.4. V is what you calculate before that. Okay. To find the density of water, James require two different measuring instruments. What are the two measuring instruments? So what are the two measuring instruments for them to find density? You need mass. Sorry, let me try this again. Two measuring instruments. To find density, we need mass and volume, right? Rho equals to M. What can we use to find mass? Electronic mass balance. And what instrument do you use to find weight with the volume? You can use a measuring cylinder. Describe a method James should use to find the density of water. You are to include two measuring instruments stated in B part 1. Right, so in this case, go and find, how do you find the measure first? Measuring the mass of the water, then how to find the mass of the water. So we need to, so you go back step by step. If you can remember, right, to find the mass of the water, you need to go and find the mass of the measuring cylinder, put the water inside, find the new mass, find the mass of the water, then after that find the volume, and then use the mass divided by volume. Okay, this one, try it yourself. Really go and try it yourself. Okay. So you need to find how to find the mass of water. Right, you can't put the water on the measuring electronic mass balance, right? Right, and volume of water, I think is easy, right? Just read off from the measuring cylinder. But now with your electronic mass balance, you have a measuring cylinder, you have electronic mass balance. How can you find the mass of the water? So I want you to think about that. Okay? Okay, last two questions. Question 6a. Figure 6.1 shows a plastic bottle on a bench. It contains liquid. The weight of the bottle is 12 newtons. The area of the bottle in contact with the bench is 0.0025 meters squared. Calculate the pressure exerted by the bottle on the bench. So we know that weight of the bottle, so we know W is equals to 12 newtons. Contact area is A is equals to 0.0025 meters squared. Pressure exerted is P equals to F over A. Have to memorize formulas. Have to memorize formulas. Okay. Now it's in contact with the bench. Is the pressure by the bottle on the bench greater than, equal to, or less than? Okay. So go back to your formula of the we have to go back to the formula P equals to F over A, right? Now let's look at this. Force, we must mention that force is the same, constant. And we can clearly see that the cap is, we have a decrease in the area, contact area, so pressure is actually increasing. So you must represent everything we wrote here on your answer. Okay? So we say that pressure increases. To answer the question, you say pressure increases. So you can tick here, pressure increases. Right? Why? Because since force, or since the weight is constant, you can tell me the weight is constant. Since weight is constant and the contact area, so weight is constant, can done out, and the contact area increases. Now you have all 3 points. All 3 points will get your mark. Okay? Okay, sorry, I should use the word greater than. Pressure is greater than. Okay, you should use better English lah. You have to use the words of the question. Using figure 6.1, 6.1, identify one physical property of liquids. Let's look at the physical property. 6.1 and 6.2. What do we see about the physical property of liquids? Right? Here and here. What do we realize? The liquid was initially here, right? So initially the liquid is here, but it has fallen down. So why? We can say that it has no fixed shape. And the explanation, okay, always remember FAM, right? Force, arrangement, motion. A, arrangement, always talks about shape, and motion will talk about volume. Sorry, the other way around. Arrangement will always talk about volume, and motion will talk about shape. Okay? You must memorize this. Okay? So your all this talk, when they ask about fixed volume, talk about, use the arrangement. The fact that they are close together, that's why they cannot be compressed. The fact that they are very close together, that's why they have a fixed volume, right? But why are they able to move around? The reason is because of the shape, right? Because of the movement, sorry. So why? Because no fixed shape. Since why? Because liquid particles are able to slide past each other. State one physical property that is similar for liquid and gases. Okay, this one is no fixed shape. And one physical property that is different for liquid and gases is that liquids have fixed volume but gases have no fixed point. Okay, and we have reached the final question. Figure 7.1 shows the heating curve of substance X. Again, is heating curve. Internal energy is internal store is increasing, internal energy is increasing. And we talk about internal store, can break it down to two things. I know that there is the when I can break down internal store into two. I have the kinetic store of the particles and the EP of particles. This one, I know that is related to temperature. EP of particles is related to state. I'm just going to write this down here. I haven't even read the question, but I'm just going to write this down here. Okay. So this is that substance X. We don't know what substance X. State the boiling point of substance X. So which one boiling point? So it has either to be AB or CDH. So we know that there are three. So it has to be solid, liquid, gas. So substance points is at CD, right? It's 110 degrees Celsius. Something is getting. Okay, sorry about this. Okay, 110 degrees Celsius. Go and confirm first. Yeah, 110 degrees. List the state of matter at region AB. Right? State. Okay, always remember this is in melting, so it is a mix. If before here is solid, after it is liquid. Right? So what is at AB will have to be, this has to be solid. My pen stopped working. Okay, so we can know that this is solid and liquid. And liquid. You must give me both. Right? Because this is solid, this is liquid. So I must be able to say that this is both solid and liquid. Explain why temperature remains constant. Fantastic question. This is a favorite question that people like to test. Okay, favorite question that people like to test. It's very, very important that we know how to explain why constant. Every time there is constant temperature, you can write down here. Every time there is constant temperature, there are two possibilities. Possibility number one, it reaches room temperature. It is cooling down and reaches room temperature. So when it reaches room temperature, we know that the top one we want to talk about, it reaches thermal equilibrium. That means no net flow or net flow of energy. Net transfer of energy. Number one. But in this case, is it no net flow? Because if it reaches room temperature, it has to stay like that, continue. But it is not room temperature. Or it has not reached thermal equilibrium. Second reason, and this is the more common reason, is that this is during a change of state. Okay, it is because of a change of state. And when we look into a change of state, there are three things we need to mention. Remember, we look at here and EK and EP. So we know that particles during here, there is a heating curve, internal energy is increasing. EP of particles are also increasing. Okay, so we need to talk about, okay, there are 3 points that we need to go. I'm going to put like that. Point one that we need to talk about is that EP increases. Point two we need to talk about is that overcome. Okay, the other way is, if it's for cooling, right, it is strengthen. Okay, is to overcome forces of attraction. That's why EP is increasing. To overcome forces of attraction. And point three, we need to go back to temperature, right? And which part is temperature? This is temperature remains constant. Temperature, which one? We need to still talk about the energy in the kinetic store. Why? Because we are still talking about temperature. Okay, so at EK, we still need to talk about EK remains constant, right? So we say that EK does not change, or EK remains constant. These 3 points will give you your 2 marks. Okay, so this is something that's very important. Always remember, I need to talk about EP increasing, because you know that it's a change of state, right? We know it's a change of state. So I need to say that EP is still increasing. EP is changing. EP is increasing because of a change of state. Why? Because they're overcoming forces of attraction to go further apart. Or in the case of a cooling curve, EP is decreasing because they are strengthening forces of attraction and coming together, closer together. But we also still need to answer the question, which is why temperature remains constant. So at the end of the day, I still need to talk about EK, which means I have to say that kinetic energy of particles remains constant. Okay, so explain why temperature remains constant. So the first one we talk about energy, or energy is transferred into the potential store of particles, right? So we still say potential store of the particles are increasing, right? Energy is transferred into the potential store of particles. Number one, checked to as it, or to overcome forces of attraction between particles as it changes from solid, sorry, this one, liquid to gases, liquid to gas state, from liquid to gas state. Okay, I know I talk about the attraction. If you tell me to overcome forces of attraction between particles, it's fine. Of course, better to actually explain to me, right, that it's a change of state. Okay, energy is transferred into the potential store of the particles to overcome. So you tell me that there is a change of state to overcome forces of attraction between particles. Because why? Because they're changing state, right? And we also say you must also mention that energy in the kinetic store, or the kinetic energy in kinetic store of particles remain constant. Therefore, temperature does not change. Okay, actually, the better term is to say average energy in kinetic store. Okay, but it's fine if you don't. At least for your level. Okay. Okay, and we are done. Oh, we're not. Sorry. Okay, so this is very, very common. Please, this is something where you need to go and get. Okay, so every time you see constant, if they ask why is it in constant temperature, two possibilities. Either it is at room temperature, either it's reaching terminal, has reached terminal equilibrium, or there's a change of state. And whenever there's change of state, 3 points to hit. Telling me that there's a change in the EP, telling me it's either the talk about forces of attraction, telling me that the EK still remain constant. Okay? Explain clearly why kettle will not be able to function. Kettle shows a kettle using to boil water. Oh, but the heating coil is, where's the heating coil? It's above. Okay, explain why kettle is not able to function properly. Okay, you can say that. Definitely we know that. Heating coil is at the top. Right? Only water at the top region will get heated up, or not only water at the top region will get heated up, but no convection current will form, as the less dense water will not sink. Simple. Okay, so you tell me about heating coil. So what's wrong in thing being on top? It's just that no convection current can actually form. Suggest a reason why outer surfaces are shiny and smooth. Again, shiny and smooth. Anyways, every time you see shiny, every time you see smooth, right? The TACT, right? Go back to the TACT, right? TACT. the temperature difference, when they talk about temperature difference, or they talk about surface area, or when they talk about color, or when they talk about texture, all this means that we are going to talk about, radiation. Okay, so it suggests a reason why outer surface are typically shiny and smooth. So again, but when we talk about radiation, we need to ask which one is hotter. Is it hotter? Is it hotter or cooler than the surrounding? We know the object here, the kettle will be hotter than surrounding, right? Object is hotter than surrounding, so we know that hotter is emit. It's cooler, it will absorb. So we need to talk about emission instead. So suggest why outer surface are typically hotter, typically shiny and smooth. First, we can say that shiny and smooth surfaces are poor emitters of thermal radiation. So when we talk about it being poor emitters of thermal radiation, so what? Right? Thus reduces rate of thermal transfer, or the rate of transfer of thermal energy by radiation. Okay, rate of rate of thermal emission. Okay, transfer thermal. Okay, right. This is the 2023 paper. All the best. Yeah, I hope you do this. These are 2024 and 2023 are two papers whereby it's aligned to your syllabus. Please go and try them, repeat them. Okay, go and do it a few times. Yeah, and also attempt your past year GA papers. Right. Thank you. Bye bye. Okay. I need to enter meeting recording.